Now that we have perfected our code to go to each year and extract all the corresponding movie titles and their links, that is, you can go to every year, let's say 2021, and we can get the corresponding titles and their links, that is Shadow in the Cloud, as well as the link corresponding to this, which is wikipedia.org/shadow in the cloud. Our goal is to iterate from 2015 to 2021. Within every page, we want to get the movie title as well as the link corresponding to it. And what this code does is, for this page 2021, it's going to collect all the movies and their corresponding links. And you know that we already loaded the page previously in our soup object, and within that soup object we are extracting the wiki table and keeping only the ones that have title and production company. And within that we are iterating through the rows, and in the rows we are finding the first italic element and trying to get the corresponding link. So let's just run this, and we are collecting all the movie URLs of this page in here. Once we run this, it will be evident. Awesome. All we did was to collect all the movie links: Shadow in the Cloud, White Tiger, Lockdown, Dig. As you can see, Shadow in the Cloud, the White Tiger, Lockdown, and the Dig, etc. So simply we collected all the movie links, and you can see them here. Now let's get to the second interesting part, which is, given a movie link, can you extract the plot? So let's just go to Shadow in the Cloud. For example, once you get to Shadow in the Cloud movie page, you want to extract the plot. So let's see how the actual plot looks like. So I'm right clicking on here and inspecting. So you can see that there is a header, and the header has this ID called as plot within it in the span. So essentially this plot name is fixed, it's always there, so that's great. So then what's happening here is, once you have the header, then everything else that you see is a paragraph element. As you can see, I'm scrolling through paragraphs up until I get to the next header, which is cached. So what's happening here is, there is the header element, that is plot, and then there are one or more paragraph elements, then there is a second header element cached. Let's go back and see the same thing. So essentially this is H2 header, then there is paragraph 1, paragraph 2, paragraph 3, paragraph elements, paragraph 4, and then there is another header element cached. And the number of paragraphs is not fixed, so perhaps we need to first identify the header element using Beautiful Soup in this page. Then we need to iteratively loop through all the paragraph elements underneath it until we exit out of the paragraph elements, and then we combine all that content to create the whole plot. So we are doing the exact same thing, which is, let's say, given a movie URL, we are going to again open the movie URL with URL open. We need to do this again because this is a completely new page. We need to open the movie URL, and again we need to create a new soup object called as soup movie using Beautiful Soup to pass in the HTML and asking it to convert it into XML format. And within that, we are trying to find the H2 element that has ID is equal to plot. not h2 element that has id is equal to plot, but there is an element that has id is equal to plot, and we are going to find its parent h2. And why are we doing this is, if you inspect on plot, you can see that there is only one element in the span that has id is equal to plot, but what we want is actually the h2 element of this, the parent of this span. That's why we are just getting the element that has id is equal to plot and then finding the parent h2 and printing that. So when we print that, you can see that we have the parent h2 element. Now what you need to do is, if you just collapse this h2 element, you know that after the h2 element you have some paragraphs that you want to extract up until you exit from the paragraphs. That is, from this h2 you want to find the next p paragraph content and get all the paragraphs. That's your actual movie plot. So what we are doing is, from this h2 we are finding the next sibling, and that exactly is the paragraph. And while that h2 next sibling element is paragraph p, we are continuously iterating and we are continuously adding into the plot. So instead of just adding into the plot, since they are next paragraphs, let's add \n. So what we are doing here is simple. We are finding the plot h2 element, then we are finding the next sibling to plot, and as long as the next sibling is paragraph element itself, we are continuously adding all this text back into a variable. That's exactly what we are doing. Let's just run this and it will be evident. As you can see, there are 4 paragraphs and we continuously added all of those, and this is the complete text. So in August 1943, while stuck, while continuing, just as Captain Reeves. So these 4 paragraphs are added onto here and we actually got our plot text. So what we achieved was, given a movie's page URL, we are able to identify the plot text and extract the text. How did we do that? We found that it's always titled plot and this is the h2 element. And once we identify this h2 element, we are continuously finding the next paragraph element and adding all those paragraph elements into a single text block, and we are calling that as the whole plot. So essentially this plot contains the whole text corresponding to this. And that's it for this section. And in the next section, what we are going to do is, we are going to combine both, which is we can iterate through every year's movies. Then we can go to each movie and collect its plot. With this combined code, we can extract all the movies and their corresponding plots from 2005 to 2021.